Let's see if we can try and make sure we keep on track for the rest of the afternoon. So, welcome back, and thanks for being prompt for the coffee break there. That's great. And I'm going to pass on sort of straight away, straight into Anand. And I should have asked. He's exactly worked out. I've now stumbled on the surname, so apologies for. But it's Anand Gonyu-Guntia. Gonyu-Guntia.
Yeah.
Okay, perfect. He's the CEO and co-founder of Centina Systems. I could go through this wonderful accolade of experience in the market, but to save time, Anand, I'll say I think obviously a lot of experience, a lot of knowledge, and now setting up Centina Systems. So
thank you.
And with that.
All right. Good afternoon. Bonjour. I guess we're in Paris.
I think it might not. We're still waiting for the dongle, so I think unfortunately.
I need to go back?
Yeah.
Okay. All right. Stay here?
Yeah. Just use the arrows, I'm afraid. You can walk around, but we'll.
Okay. So there are a lot of great presentations over the last 2 days from service providers, from vendors. And I think we can say a few things for sure. It's real, right? The SDN, NFV, and the open innovation is absolutely a reality today. Just about a couple of years ago, it was a vision and thought process. Today, I think there are enough products that make an application a reality. A number of projects have taken place where good limited deployments are tested. Not entire network can be virtualized, but there are pockets where it absolutely makes sense right away to go deploy these solutions, and there is enough commitment in all directions to make this a reality. There are several folks in this room. We've been in this business for long enough. A lot of technologies have come and gone over the last 20 years, but the fundamentals remains same. For a technology to be very successful, rule number one is the value has to be a very recognizable value, and that's by all the stakeholders, right? It has to be a win-win. From a provider perspective, they need to make an investment, and they need to make returns on that investment. And from the customer perspective, they care less how we deliver service to the end customer. If they get better value for what they pay and the service is delivering their needs, they're good to go. I think one thing we can say is at least 3 to 4 different applications where I think we've already achieved the first objective. I think the presentations last 3 days have proven it, and we've been working with a number of operators where we can definitively say that the first rule has been met from a operator perspective, right? So what are those applications? The first and foremost applications that we see is being ubiquitously looked at is virtual EPC in the mobile core. If you look at that cloud, all the different pieces of components historically has been appliances, and they're very, very easy and relatively not complex to move into the SDN NFV domain. And the benefits here for carriers is to be able to disrupt the pricing, how they deploy these things, how they negotiate with those vendors, and how they can leverage this technology not just to replace what they already have, but for incremental benefit. So, for example, if you're doing an M2M application or you're growing pockets of your network, this would be a great way of leveraging this technology. Software-defined WAN. I think there is a decent acknowledgement that there are ways to optimize the cost the enterprises have to incur in deploying their WANs, and SD-WAN gives a promise for end customer, and also for the carriers. There's a benefit to the carriers in rolling out this as a new service, so their investments are more justified in possibly making this a managed services offering and creating additional value in the services they sell. We talked about a lot of vCPE services. I won't bore you with that. The point here really is that we absolutely are sure at this point there are 3, 4, 5 different applications where business folks within the operators can go justify investment. They've already proven the technology, and they can take it for prime time. Although today, most of the testing that's done in the lab or even to the customer is with very small scale deployment. So the focus has been a lot of product planning, product management, strategy, and business type of organizations within operators, evaluating the core technology. Can we do it? Okay, fine. Can we roll it out at a limited quantity? Is the customer getting about the same service or not? And that's all they're worried about, right? So they're testing those aspects. But what is the really second and the most important thing for this technology to sustain? If a carrier has to continue to make the investment, they need to get the customer acceptance of this technology. The customers need to get it, and the carrier need to be able to scale it from 1,000 customers to million customers. And that scale requires different thinking. You got to think about the people that would be dealing with this technology. Like I said, there are a few handful of people in each operator that's focusing on the technology today. But when you roll it out in mass scale, you're dealing with customer-facing organizations, network operation centers, service operation centers, customer care organizations. Now, folks, these folks are not as highly skilled in all the shifts as some of the R&D and planning folks that are looking at virtualization as technology. All the buzzwords don't make sense to a lot of these people, right? So when an angry customer calls them, they need to have capability, whether it's virtual or physical or whatnot, to get to the bottom of an issue and make that customer happy, right? So if you don't do this, the service will not take off. The revenues will not come in as fast. As a result, further investments will be held up, right? End of the day, we invest in areas where there is sustainable return. So on this front, I like this quote. Things are going to be quite challenging in the next year. For those who are looking to roll off and hand off services in a big way, I think a few aspects you need to be thinking about. Things are going to get extremely messy because you're going to transition these technologies to different type of people within your organization that are used to their methods. They're going to fight it. But they need also tools that you need to bring to the table and convince them to look at that gives them value, make their life easy, make their life simple in the way they deploy, deliver, and make the customers happy and keep the customers happy. So just to give you a context, Mano has done a great job in defining all the different layers. All the bottom layers are pretty clear, but if you look at the top 2 layers, the OSS, BSS, and orchestration, really, you got to ask the question, why is that the existing OSS cannot handle the virtualization? Why do we need yet another layer of orchestration? Very simple. The legacy investments are done to manage physical assets, and orchestration is redefined, essentially providing similar functions, but for virtualized assets. And if you take one more level deeper look into it, you have orchestration essentially doing the fulfillment functions of a traditional OSS system, but on virtual assets. And assurance within orchestration is really assuring the cloud assets. And it can go broader in scale, and I'll talk about that briefly. And everything that goes, all the interactions between this fulfillment and assurance are very, very critical component. Again, like I said, the fulfillment side is what getting attention at this moment because that's what need to be done to test and verify and validate initial deployments of technology. But very quickly, very soon, as you roll out, assurance becomes a very important facet of making this whole thing a success. So what are the things this assurance need to deliver to the user community to make their life easy. And I could capture a number of things, but I had to trim it down to a few things so I could get it done within 15-minute time. The first and foremost thing, the cloud assurance need to know the assets it's managing. Traditionally, carriers using the OSS assurance manage physical boxes, whether layer 1, layer 2, layer 3, or layer 7, right? But looking forward, you need to manage servers, OS, cloud software, and NFVs, and all the things that go in a traditional IT type of operation. So the cloud assurance need to have easy ability to talk to these layers that are totally different from how the traditional OSS are doing assurance today. Monitor physical infrastructure at low level, right? So you need to be able to use all the new assists that are being developed by Intel to be able to look at the processor core, the servers. Servers are moving from enterprise class to carrier class. They're instrumenting a lot of new things that enables to give you telemetry information both in a reactive and proactive way. And this assurance should be able to, at a bare minimum level, be able to understand how to talk to compute storage and the networking that's provided at the PNF level. Okay, I'm throwing one example here, OpenStack. Most of the deployments we're looking at for NFV has been either OpenStack or VMware. That does not eliminate all the other options, whether it's ODL or ONS, or who knows next year what will come to the table. You know, simply looking at OpenStack, it's 11 unique applications. There could be 40 to 50 different failures within these applications. And there are a number of metrics that are relevant in forecasting what would happen to a specific OpenStack instance. So imagine a data center that's distributed in 10 locations with thousands of servers, thousands of these instances. We're talking about real-time monitoring tens of thousands of pieces of information and stitching that information to be able to forecast and say, hey, this part of your operation is at risk. Now, OpenStack is evolving, right? And so is ODL. We had speakers talking about thousands of developers contributing into the open source community, and now there are thousands or tens of thousands of software commits. What does it mean? You can look at the chart. You know, when it started in 2010, there were 2 applications. Today, it's 14 applications. 2 years down the line, maybe there'll be 20 applications, and they'll be far more richer than what they are today. So, as a cloud assurance, the vendor has to make a commitment to the platforms they're supporting and invest in understanding what these platforms are all about and build probing capabilities that the carrier and the deployments can leverage and understand how these platforms are performing, right? So you start with hardware, you start with cloud, and not only start with the cloud, you keep up with it. VNFs, and we had customers talking about, well, we have 50, 60 VNFs in our pipeline, and by the way, we want to reduce the time to market. By the way, we want to reduce or we want to shrink the cycles of product life cycle, right? We want to introduce something. If it doesn't work, we want to get rid of it and start reintroducing until something clicks. And what does that mean? When you introduce new technology into network, it's not like a lab. You know, you introduce into customer environment. You need to be able to roll this in within days and months, days and weeks of time frame. And these VNFs are being reinvented by day, right? We're talking about DevOps. So within a few days, you need to be able to not only accommodate a new VNF, you need to be able to keep up with the multiple VNFs. So you need to have some sort of an app delivery model. You know, just like iPhone today, you know, you download an app, you don't worry about what version of iPhone you have, what version of app you have. This should be very similar to that. You download a VNF app, and it knows, the assurance platform would know how to interact with the VNF, how to keep up with the changes that are happening in the VNF, so the users of the solution don't need to worry about the nitty-gritty detail of how to interconnect the orchestration assurance platforms with the infrastructure that they're managing. Integrate and remediate. So there are a ton of orchestration engines, folks developed in-house and folks that are buying off the shelf. In orchestration, the biggest use case is to be able to model a service that's very abstract and be able to activate the service. And if you have 500,000 customers, 500,000 services, you do those 500,000 things over multiple months or multiple years. So the transaction volume of an orchestration engine is relatively small compared to what you do in assurance. So the assurance systems need to be able to collect data at all layers and be able to take remedial actions. So first part, they need to be able to integrate relatively easily with orchestration platforms, get the service information, and be able to pull or collect data from various assets that are provided by the infrastructure, and be able to remediate the information back to the orchestration platforms, and all in real time. Now, if you're a network operations center guy, you're a customer-facing guy, and or a gal, and you get a call from the customer, the most important thing is to be able to isolate a problem, right? So you need to be able to visualize what is the asset, what is the service, and I call this vertical relationships. Vertical relationship, anything that goes up and down the stack, compute to virtualization layer to VNF, and to be able to pick any piece in that hierarchy and be able to see how things are tied together with respect to what's happening in the infrastructure. And that's how they can isolate the problem relatively quickly. Because as we know, the whole notion of this technology is things change real time. You react to the needs on the network or the customer, and you enable changes on the network. By definition, when I am the guy who is looking at the infrastructure, I need to know what's happening with respect to that customer at that instance, with respect to what's being provisioned. Second is horizontal relationships. We talk about service chains. Service chain is a very simple example of stitching different components of NFVs. Now, you stitch it, and this stitching could be 10 NFVs in a service chain, and by the way, there could be a WAN component, there could be VNF component, and you stitch it and you provision it. Assurance should be able to look at same horizontal components and be able to come up with assessments that can help the users to troubleshoot and be able to isolate the problem. We hear about performance and root cause analysis, right? Now, what is root cause analysis in virtualization world? It's really correlating data coming from applications and virtual physical networking components and applying that against the construct that's provided by the orchestration and be able to get to quick decision points. Now, this is very different from physical things that are tied, where things are not changing very much. You know, you have terminology. I promised myself to not use buzzwords here in this presentation. So, in a simple term, you need to be able to take any specific request and be able to do a root cause analysis. And it can be done very easily in virtual world than in physical world. If any one of you deal with the inventory systems and the inventory of your networks today, it's very difficult to keep it accurate because they're all offline systems. With cloud and with virtualization, that's one thing that's changing. Your repository, your inventory is actually driven out of the orchestration system, so it's always assured to be accurate. Always assured to be accurate. And it's also connected to the infrastructure, so we can always get an accurate reflection of what's going on, and thus root cause and correlation can be accomplished easily. Same thing with service impact. Let's say you have a blade failure, you have a fan failure. What does that mean? Do you have redundancy, non-redundancy? If this failure has happened at a physical layer and a blade is gone, how many VNFs are affected? And what does it mean to your service chains? How many customers are affected? How many are able to roll in with the resources available, and how many can be rolled out? And these type of analysis need to be available to the users in real time. Trending. Trending is basically what's a baseline, what's a normal operation. These systems need to be able to understand a normal operation, so they are able to detect deviations and project the deviations to a future fault, and also be able to provide this data as a feed into whatever is the analytics engine that's available. So being open architecture is extremely critical. Automation. We talk about automation. You know, it's not just remedial actions. It could be basic automation that could be done within a operations center. So let's say there is a set of infrastructure. Let's say you have 5,000 instances of a VNF. A set of things go wrong, and over a period you detect a pattern. there's really no need for a human to be involved in fixing that pattern. Once you master it, you create a workflow that can actually go and fix it. The workflow-based remediation and actions are equally critical as well. And finally, it has to fit in the cloud, it has to be open, it needs to expose all of this to be integrated into the ecosystem in agility, DevOps, all wonderful things, and they're important. I'm going to run very quickly through my rest of the slides. Managing hybrid environments. There is a need for end-to-end management, although this is a little farther out use case. I want to throw it out there. It can be done. It can be done, but having the roadmap to be able to achieve this is also important. So recap. These are the 14 things, and there are a number of other items that could be very relevant depending on the application. So with that, I'll end with one of my slides. We're not a Huawei or Ericsson or Nokia. So Centina Systems has been in business for 10 years. We help fixed line, mobile, cable MSO operators. Our new offering, vSure, addresses the assurance orchestration. NetOmnia is our other product. I'll take any questions here on.
Right, great. Thanks a lot, Anand. Do we have some questions? I'm not sure. Any questions? We have one at the front here. Ken?
Thank you for presentation. I saw in one of the slides you mentioned about virtual firewall. Have you considered the security part also for assurance?
Well, the security part is typically addressed at the VNF layer. When we are assuring a service, we default assume that the firewall appliance or firewall NFV has the security built into it. We would leverage whatever is the mechanisms that would need to be applied. Essentially, how a human would interact with a firewall would be how this type of software would interface and interact with the firewall.
Okay, so firewall is the only mechanism you have considered.
There are all kinds of other mechanisms as well. Like today, that part is not very different for the physical versus virtual assets. The network side, there is a lot of difference, and I think a number of speakers have alluded to various ways that'll impact. But from monitoring and assuring the service and the service delivery and SLA component, there's not a whole lot of difference.
You mean you are not going through the prevention mechanism?
That's correct.
Okay,
Thank you. Yeah, you're welcome.
Do you have any other questions? Yeah, another one at the back there. Yep.
Oh, thank you. Hi, I'm Kumutini from Juniper Networks. Say if we have a scaled environment like 10,000 switches in the data center and 100,000 links, have you done any benchmarking, like how long it takes to detect a failure, link failure, or is it in the order of millisecond and nanosecond? And especially with scale, things can get really complex.
Right. Actually, a very excellent question. Excellent question. In fact, this is my early point. When you deal with orchestration of a service, you're not talking about the scale that we have to deal with as an assurance player. We're talking about collecting millions of data points, and correlating them within seconds and minutes. We have benchmarking. When we're talking about these data points, they tend to be unstructured data, logs, events, autonomous messages, metrics, raw metrics, and we need to pile on all this information as fast as we can. And by to some extent, the infrastructure itself will limit us, right? There's only so many times you can ask it for information from the devices, and sometimes they send packages up to us, but they also send those in certain seconds. So you do get some leverage there, but the architecture of these solutions takes into account that scale. We have deployments where we're managing million devices and collecting 5 to 10 million data points within a window of 30 seconds some and 5 minutes others, and be able to come to decisions. So 10,000 switches is almost a pittance. So if we need to achieve milliseconds, we're basically limited by as fast as the data is available on the infrastructure. But absolutely critical thing we had to address, and we did.
Okay, thank you.
Okay. All right, great. For time, I think we need to move on. So thank you very much, Anand. I mean, 14 things to remember. Is that all we got to worry about?
Yeah, thank you.
Okay, thank you very much.